I'm a writer. I'm an author. I've got perhaps 8 or 9 books published in French in France. In English, I've got at least four or five books published. Novels, poetry, essays, philosophy, and then the last one is New Age physics. I think it's reversed. Anyway,
No, it's not reversed on my side.
Oh, great, perfect. But I was a court clerk in the Crown Court in Isleworth in London for 12 years, and I've worked in conferences before that, producing conferences. I've got a master's degree in French literature, so not physics. So my book cannot be that complicated, because if I don't have a degree myself in physics, and it's just learning online and everything about physics and trying to figure out everything, then everybody can understand it, because I don't go into lots of details or equations or proof or anything like that. So it's more philosophical, physics.
Well, I like that already, because I have this view that science should be open source and has always been open source. It shouldn't be relegated to people in white coats with a stamp on a piece of paper.
Well, exactly. They used to have a very nice kind of relationship. There was Germany, France, and England. The UK. They were, all working on physics and writing stuff and reading what the other was writing and coming up with new ideas. But with the peer review process now, everything that can be against Einstein or Newton, certainly would not pass. It would never be published. So it's a bit like all the stuff about COVID-19. It's very censored, and if you were to say that Einstein was incorrect on anything, you'd be laughed out of the door. So probably lose your career. I don't know. So it's very difficult for people with alternative theories, and even within theoretical physics, it's very difficult for them to move away from the standard physics, if you want.
Okay, so basically you're arguing that Einstein was wrong on a bunch of things.
Yes, and not only almost everything, to be honest. And it's all been misinterpreted, and it's all fallacies. That everything that he said, disproves that. There's always a different interpretation. It's like quantum mechanics as well. There's always a different kind of explanation or interpretation that you can give to something, and they don't seem to have looked very hard to find them for a start. And physics should be very simple and very easy to understand. If it's becoming like only 5 people in the world can understand it, like quantum mechanics, then there's a serious problem. And it's got to be mechanical in nature. You need to be able to see particles, and they need to be able to move, and you might be able to explain what is going on here and in the interactions. It cannot just be mathematical, otherwise, yes, you can. There are theories, so you can reach good results. Like Einstein, you reach very good results, and Newton as well. But there are, alternate theories, but they explain the same observations. So that's the thing. So, for Newton, if you've got gravity for Newton, is like these 2 balls are emanating like some sort of attraction, and then the balls come together. This is what gravity is. But we never seen this attracting force, and we don't know what the power source is. So for Einstein, it's the whole space-time is actually a sheet of paper that can be bent, that can actually be pierced, and reduced to nothing, from which a Big Bang can start. It's like the singularity. So in atomic expansion theory, there is no more Big Bang, there is no more singularities, there is no more black holes, there is no more wormholes possible, because there is no sheet of basically space-time that can be bent and everything. But the idea of gravity in atomic expansion theory is that matter expands, and so, but we cannot see it, because if you are expanding yourself, how could you see that matter expands, that everything is expanding at the same rate? Which is a rate of 0.00000077 per second square. Sorry. So if matter expands, then the distance between objects reduces, and that's the same thing. And if you've got 2 big balls here that are expanding, and they are passing, each other in a parallel opposition, if we cannot see the expansion, what happens is that they don't change size, and then you can see that it becomes a natural orbit effect. So that you can see now what orbits are or why they exist. Because with the expansion, but when it doesn't, if it expands, they just expand and they just pass each other. But if it doesn't expand because we cannot see it, then there's a relative motion effect for which that the distance reduces, but the object remains the same size from our point of view, and then you get an orbit. So this is what gravity probably is. It's like everything is expanding for a reason that we don't know about, but all matter, all particles, and then the rate that I've just said, and this is why the distance reduces as things expand, and we cannot see the expansion.
Okay, hang on. There's a lot going on there. So let's just break some of that apart. You mentioned gravity. Something that I have been fascinated by is exactly what is gravity, because it cannot be reproduced by humans.
This was Newton's idea, just that there was a force attracting, an attracting force acting at a distance, where the masses were attracting each other, and from that on, he came up with an equation, but his equation was based on observations. So if you observe a phenomenon in nature, you can always come up with an equation to explain it. It's like Galileo came up with the acceleration multiplied by t square. It gives you the rate at which an object falls onto the Earth. Maybe I've got it wrong, but it's about that. Acceleration multiplied by time square. And so when an object is falling down to Earth, what is happening is that the Earth is expanding by 4.9 meters per second each second, and the object falls to the Earth. And the acceleration for it, the Earth is expanding to catch up with the object. The object is actually just floating in space. And what I'm saying is that the distance reduction between the object falling and the Earth produces one, because the objects are expanding, so that's the absolute reduction in distance in gravity. But there is a further relative decrease in distance because space does not expand with the objects, with everything else in the universe. So space is a void. So a meter before the expansion is half a meter after everything has doubled in size, and everything doubles in size every 19 minutes. Now that sounds very alarming, but we don't see anything expanding. So in our resulting reality, nothing is expanding. So, and there is a lot of space, behind it. But so this relative decrease in distance, because space doesn't expand with everything else, if you're going 30 miles away in space, and it takes you 19 minutes to get there, by the time you get there, there's only 15 meters of space, or kilometers, or whatever. So this is what the acceleration is. The relative decrease in distance is why there is an acceleration. So if you're going to a destination that is 50 miles away, and then everything's expanding as you go there, and space is not, by the time you get there, all the distances have shrunk. And because everything has expanded. But, orbits counteracts gravity. So, we're always at the same distance from the sun, the Earth, when it's orbiting. And, electromagnetism also can counteract gravity. So these are two things that, can keep gravity apart.
This expansion idea, if you can't observe it, how do you know that everything is expanding?
It's a theory, but there are proof. I don't know if people search on YouTube about how a slinky falls from a building, they will see something extraordinary that neither Newton or Einstein can explain. That you actually hold the slinky in your hand from the top of a building. You can even see it from your own height. And when the slinky falls, it will actually it will be suspended in the air, the base of it, and then the whole thing will fall down, and only when they touch, suddenly will go down. So it's levitating. The slinky is levitating in the air, the base of it. And if you have to slow it down to really see, but it's several seconds. It's a massive slinky, and it falls and falls, and this is levitating. There is no way with an Einstein or Newton that it could levitate the base of it, because with Newton everything falls immediately. And if you've got a massive big funnel like that, and you've got an object that's going to fall in Einstein, as soon as it's at the top of the funnel, it will fall immediately. So the only explanation for this is that when you have a slinky and you let go, or a spring, both ends comes back together. You know, there is not one that stays there without moving and the other one coming down and then fall off. So what's happening is that the base of the slinky is moving up while the top is going down, and then it's because the Earth is expanding at the same rate that the base is going up. So you can see that the base of the slinky is going up, but you can't see it because the Earth is expanding with it. And the stretch of the slinky was because of the expansion of the Earth in the first place, because you were holding it, the stretch, you know, while you were being pushed up by the Earth and the slinky was coming down. So that's one proof. Another proof is that the Pioneer anomalies, I don't know if you're aware, the spacecraft that have left the solar systems. You know, as long as something is in orbit around the sun, you know, you cannot see any difference because everything expands at the same rate, and the orbits of the planets also expand, you know, in a spiral, you know, and so you cannot see this. But if you don't have something that is orbiting like the Pioneer anomalies, the Pioneer spacecraft, they start decelerating. And they're decelerating, they've called that the anomaly, and they have actually proposed some solutions, but none of them are very credible, like gas leak or something. It's because the solar system is expanding towards it. And because the solar system is expanding, it's actually reducing in distance. And in reality, it's not reducing in distance. It is going at exactly the same space, but it's a relative effect that makes it really decelerate as the solar system is expanding. There are other proofs like that involving springs and things. So, you know, you come up with theories, and then the ones that can explain everything is actually the one that you should adopt. And to be honest with you, it explains everything in physics. Just the expansion of matter and the contraction of matter as well explains everything. Like electromagnetism, which is a second force of nature, it's the expansion, the growth and the shrinkage of the electrons themselves. They can grow and they can shrink, and if you've got many of them and you've got clouds of them, then they can actually push each other. So that's the repulsing force of Coulomb. And if they actually are kind of the same density, they will all shrink back. So that's the attracting force of Coulomb. And if they are kind of different densities and they are kind of stuck, then you've got static electricity, and you've got massive big clouds of these electrons. And clouds of electrons in atomic expansion theory are magnetic fields, and clusters of electrons are photons. They are light. So that's the difference, you know, from Einstein. So photons are no longer kind of intangible particles, you know, made of energy. They are actually clusters of electrons, and the size of them defines their wavelength and their colors, and if they are, you know, heat, light, or visible light, or ultraviolet, or X-rays. And the size of them means how many electrons, clusters of electrons you've got per cluster.
So this means that relativity is not real.
There is a relativity to motion, you know, and in my theory, you know, when objects are moving towards you, they're not moving, they're actually expanding. And then if they are moving away, they are just shrinking. Because the reality is actually psychological in nature. You can only be a representation of your own brain within your mind. And you receive signals, you know, made of, you know, electrical signals or electromagnetic signals, and then it gets into your eyes, and then you can actually represent reality in your mind. So at this point, there's nothing really real. There is no distance in the universe. When the UFO disappear and reappear, it can go anywhere, at any distance, at any time, very quickly, because it's shrinking away to that place where they are, or it's expanding towards where they want to go. And so there is still a relativity to motion. So we will still need kind of transformation equations like Lorentz to actually find out where something is relocated in space compared to where it really is, because light bends as it actually passes between, you know, near star, you know, it bends, or galaxies, it bends. This is the gravitational lensing effect, which actually confirms Einstein's theory, but you don't need Einstein to actually explain that. You know, asteroids passing by a star will actually bend because of the expansion of matter. As the sun expands, and the light will actually go in a partial orbit around the sun, and then so the distance between them reduce. But since light goes very quickly, then actually it will continue on its course, but it will actually reduced the distance, so it will have changed path. So when you look at the light, when you receive the clusters of electrons into your eye, something that you look, it will seem that a planet is there, a sun is there, but it's actually not there. It has bent a lot before it arrived to you. So these are and the relativity is like for relativity motion. Special relativity of Einstein is about the relativity motion relativity, and Galileo had one too. The Galileo relative motion is probably best. This is probably what we should go back to instead of Einstein, if you don't want my idea that actually everything is actually expanding or shrinking with motion from your point of view, and there is no distance in the universe. So there's always other explanation for, and general relativity of Einstein. It's more about motion with speeds, and then the gravitational field will actually affect. There's a whole bunch of things about Einstein, that have been misinterpreted, basically.
Well, also the fact that he has been cemented as some sort of god. You cannot question him, and that is obviously an unscientific approach anyway. You should be able to question him.
Yes, and many people have questioned him, but not officially perhaps. But they still cannot move away from it, because it is so everywhere. It's actually the base of every theory there is. So even quantum mechanics, gravity theory is actually based on Einstein. So it's very difficult to get rid of him. There are 3 people perhaps at the moment in the world that have an expansion theory at the base of their physics. There is me, there is Mark McCutcheon, which I work with all the time, and this is his book, The Final Theory, Mark McCutcheon. And there is also Miles Mattis. I don't know if you've heard of him, but
yes.
All right, you've heard of him. He's got lots of physics as well.
Yeah, he doesn't do interviews though.
None. And, it's probably a good idea. Mark McCutcheon doesn't do any interviews either. So I'm the only one speaking on the subject. But Miles Mattis, even him, has actually kind of moved away from expansion theory. But he kept... He's found an equivalent kind of idea about the spinning universe that can actually create this acceleration towards everything. But there's still, I think, an expansion, but it's reducing. It's prevented from going any further by something of a charge field that he's got. I don't want to speak too much about his theory because I'm sure he doesn't like very much, but people should check it out. But he's got an expansion theory as well. So, and he kept... Miles Mattis kept Einstein and relativity and everything, because he went another different way than Mark McCutcheon. Mark McCutcheon doesn't need it, and my theories are based on Mark McCutcheon, where it doesn't need Einstein at all. And there is other alternative explanations for everything, and for quantum mechanics as well, which has been misinterpreted, basically.
What happens if we drop Einstein?
That's it. The problem is that... there's a lot of things that goes on. First of all, there is no more photons, so there's no more kind of energy. Energy is actually particles in motion. There is also that the speed of light is no longer constant. If the speed of light is no longer constant, then we can go faster than the speed of light. We can go anywhere in the world, in the universe, I mean, much faster than the speed of light. And light will still arrive at you, because although it moves at the speed of light, there are particles that you will eventually see, or your camera will register. And then you will either see in fast forward, or in slow motion, or frozen in time, or in real time if you are at rest compared to the object. So there's no more speed of light limit for a star. Second, the speed of light itself should be relative instead of being constant, because it is something that you see, and different observers will see differently depending on where they are. So the speed of light should be relative instead of constant. And time for Einstein is actually what is relative. So the time rate can change. So not anymore. The time is constant everywhere, here on Earth, in space, and also in all dimensions, if you want. So if time is now constant, then there's a big difference from the point of view of Einstein. There are also, since the speed of light is now relative, it can accelerate. You know, when asteroids goes around the sun and they actually enter into a partial orbit, there's a slingshot effect, which is a relative motion effect due to the expansion of matter, and so light has got the same thing, so it will accelerate. But on Earth we will not see this that clearly because it's also slowed down by a lot of particles that it meets along the way, like our atmosphere. So we may always measure the speed of light to be c, which is about 300,000 kilometers an hour, but I think that you will find that in space probably the speed of light is accelerating a lot, a great deal. But you know, the original speed of light, which is most of it, comes from when they are ejected out of the atom. This is most of their speed, and at that point then they are subject to gravity.
This would also mean that there'd be no singularities, no Big Bang, no black holes, no wormholes.
So this idea of a black hole was not generally accepted at the time. You know, it was really actually there was a lot of opposition, there were lots of alternatives, and as if Einstein goes, then there is no more singularities. At some point, there was no Big Bang where out of nothing came the whole universe. Anyway, they cannot find a central point for it in the first place. The further we look into space, you know, even if it's 14 million light years or billions light years away, we still find old galaxies. So, and the idea of the Big Bang should go, and in expansion theory we don't have the Big Bang, and so you know there are three options: either the universe always existed as it is, or there was a creation event, and the creation event could be a computer simulation, or it could be God thinking something. Our brain is like a biological computer, if you want. So if I can think something. If I went in prison for 20 years and the only thing I had in solitary confinement was my mind, I would perhaps try to create the Earth and everyone on it and identify a few people. There will be non-playing characters, but there will be a few that will follow and things. I can think up something like that. So a God could have actually have created something like that. And if we are within a simulation, if I can do that myself, a God within a simulation could also do that. But so either someone thought this reality, the universe into existence, or it's a computer simulation, or you know, it was always there. And even if it's a computer simulation, or even if it's a God creation, there could have been an evolution, because you can actually, when you create something, you can say, okay, I want all the signs that there was an evolution. I want all the signs that billions of years have passed, even if the world had been created this morning when you woke up, you know, or you know, for I don't know how long ago, you know, more recently than you think. You can create the world as it is, and there's always a past, even the past doesn't exist. When you dream something, there is a past, you know. You are in a situation, probably at work or something, and you interact with people and you remember things that happened before that event in your dream. So there is a past that exists there that you never lived. So reality might be very similar, you know, and the past might never have been, even though it was a creation event. So I don't know which option it is in those three, but they are all possible. The possibility of a computer simulation is certainly very high, you know. After Mike Bostrom or something from Oxford University or something, his paper was very convincing. So it's very likely that we live in a computer simulation, especially with the advent of AI. You know, if God has any kind of mind like AI, I'm pretty sure he can think up a whole universe with billions of people on it very easily and control all that without any much problem and be everywhere at once.
So expansion theory is actually compatible with the sort of David Icke view that everything's a simulation, and it's also compatible with a Christian or a religious perspective that there's a creator, but it's not compatible with flat earth theory.
If I haven't read much about flat earth theory, but if people were to try to explain gravity using the expansion of their flat earth, I'm sure they can find a way. It would be easy. So it could be compatible with that too, and it will explain also what anti-gravity can be, you know, because anti-gravity is very interesting in an expansion theory, because if the earth is always expanding, how can you create anti-gravity? It's like there's nothing you can do, because the earth is always expanding, and it's expanding, the distance reduces an acceleration. You couldn't have anti-gravity, so how do you explain UFOs? You know, they are floating up in space. They don't seem to be using any kind of propulsion. They can float out completely up there, and no propulsion, no noise, anything. So what is anti-gravity here is actually buoyancy. You know, when you've got a balloon of air in water, it goes up to the top because the density of the air is much less dense than the water. And if you've got a balloon of helium, which helium is a gas that is actually not very dense, it's one of the early, I think it's the second gas or the first one, I can't remember. But it goes up in the air as well because it's less dense than the atmosphere, the composition of the atmosphere, which is nitrogen, oxygen. And so the UFO is the same thing, it's buoyancy. But what is happening here is it's the particles. You know, when you've got the electrons that expand or that shrink, you know, they can if they go, it depends on their speed. If they go very fast, our orbits go faster, then it vibrates faster, so the frequency is higher. And so what's happening is that all the particles enlarge and they're all vibrating faster, and then the molecules, the atoms, they are expanding, they are larger, they are also more spaced out, and it changes the density of matter. And this is what I call the interdimensional density of matter. And that explains, and then this is less dense than our own dimensional, interdimensional density of matter, so that's how they can float. So it all makes sense, you know. So this is what anti-gravity is. As long as you get your particles go faster, then everything enlarges, everything is more spaced out, and what happens is that you change the dimension. The dimension, this is what it meant by that, is the size of the objects, is actually the size of the particles. And so that you move to another dimension. So the frequency is how fast all these particles are spinning. So this is how anti-gravity can be explained. And other dimensions, that's why ghosts can appear and disappear also, because their particles are moving either faster or slower than what our senses can actually see. And that would explain why a child that might be vibrating faster at a higher frequency would see a ghost while an adult won't. And the same for UFOs.
Sorry, just to go back to your helium balloon, gravity doesn't pull it down. That's also quite interesting.
Yes, this is what buoyancy is, and this is how these massive boats on the ocean can float, because the density is much less than the water. So the helium balloon, if the gas is, this is a fact of physics, that anything that is less dense will be pushed up above what is denser. And if you've got these kind of, you know, the differences in density of matter all the way from here to the middle of the galaxy, then you just have to adjust your frequency of matter to be at the same rate at that it is at that location. And even time, you can even time travel. So if you adjust your frequency or your vibration rate of matter, you can go anywhere in the universe instantly, and you can also at any particular time, because everything anywhere has a unique frequency, and we don't all live in the same dimension. If you want, we all have an individual dimensions, but when you've got a certain kind of scale of dimension altogether, then you call it the fourth dimension. And you know, if you've got which we are in apparently, and then no, we are in the third dimension, moving to the fourth, I think, because time is no longer a dimension now that Einstein is gone. So time is just constant. But if your particles are vibrating faster, your time rate will seem to be faster, even though it will actually be taking at the same speed. You can accomplish more tasks in the same amount of time that someone who's vibrating slower. So in that way, time could all still be said to be relative, although it is constant. Because if you look at it, the planets are not moving faster. So time is never going faster. You can just do more in the same amount of time. So in other dimensions, you know, 1 of our day can be a year for them. So that's one thing of expansion theory, or my theory anyway.
Okay, so Einstein argued that the speed of light is constant, and the expansion theory suggests that the speed of light is not constant, and that time is constant. Is that correct?
Time is constant, and the speed of light is no longer constant. It is actually variable, and also it is relative, so it changes. So but on Earth it's usually around c, so we need to keep that in mind. And if you look at his as equation, E equal mc square, which is mass, energy, kinetic energy, because this is what it is about. Kinetic energy equal mass multiplied by the speed of light square. If you change, since the speed of light is constant, if you change the kinetic energy of an object, which is the force of impact it will have if it hits something, only the mass can change, because the speed of light is constant. So that's a problem. And the mass is relativistic mass. The mass doesn't really change, but from the point of view of someone, the mass can become infinite, like in a particle accelerator, but it is not. Basically, this is the speed of light that changes. And the mass always stays the same. So you see that's a massive difference with this equation. We might as well, perhaps, you go and use the kinetic energy equation, which is Ek equal half mv square, which is almost identical to Einstein. So, there's only a half there, and it's because of calculating average of speeds, but v is velocity. So, yeah.
Okay, so light in expansion theory is not made of photons, but of clusters of electrons.
Yes. And, for Mark and Mars, the speed of light is not accelerating. These are my ideas. So, and it makes sense, as I said, that the speed of light, the light is made of clusters of electrons, and there's not much difference. You could still call them photons, but if they are clusters of electrons, then you can have different sizes. You could also have different sizes of photon. At the moment, they don't say that, but they've got a mass. That's the difference, and they've got a shape and a volume. But in my theory, everything is the same. When you've got an expansion theory, everything that is extremely small, like particle physics, quickly become extremely large, like astrophysics. So it's the same thing. So an electron is actually a solar system. They are the same. So you've got a nucleus, which is the sun, and you've got planets that orbits that sun. And so I've called them neutrinos in the electron. So you've got a super neutrino as a sun, you've got neutrinos as planets, and you've got some neutrinos as moons. So you can imagine that an electron is exactly like a solar system. And so when electrons are interacting together, it's like other solar system interacting together. We will find probably other planets orbiting very far from our known 8 planets, where actually connects us to other solar systems. And together they form, larger particles, such as neutrons, protons within, an atom. And those are basically just a collection of solar systems interconnected together. And the galaxy itself is actually an atom. So an atom is made of electrons, like a galaxy is made of solar systems. And then you've got a molecule after that. So the molecules are made of atoms, interconnected together by electrons. So at a larger scale, you've got galaxies interconnected together by orbiting solar systems. And so you've got cosmic molecules. So altogether, what we're looking at the moment, when we're looking at the night sky, it could be something. It might be alive, it might not be. It might be a rock, a fish, it might be God. We might be inside God. That will explain why he's everywhere. And from what I calculated, everything that we see in the night sky at the moment is about half the size of a cell. So if it was to be alive, we should be able to see patterns in the night sky of things that you would normally find in a cell, like DNA, RNA, organelle, things like that. So this is quite a big change from normal physics, and to make all this work together, I can tell you, it's quite something. But it's all based on expansion and contraction and growth of matter.
Okay, so if everything in the universe is expanding and doubling in size every 19 minutes,
including
at a
the
constant
universe.
rate, including the universe, how is it that the Earth and Moon are not getting closer then?
Because, as I said earlier, orbits is a way to counteract gravity, and orbits are, as I explained, it's all due to the geometry of expansion. So, Einstein, his theory was geometric in nature because the space was bent, space-time was bent, so it had to obey geometry. Newton's, it was like an attraction at a distance. You've got vector forces. So at that point, it's not geometrical. And then expansion theory is that if things are passing like that in space, as they expand, they actually expand like that. But if they are staying the same size from our point of view, only the distance reduces, but the objects remains the same size. So that's when you get an orbit. And the orbit, the objects are going totally different directions, very fast, behind the scenes. And that's what we call the God's viewpoint, because we can never see that viewpoint. But if you could see the expansion of matter, this is what you would see. And this is how you can actually explain the mechanics of the universe, is that by seeing what's happening behind the scenes, if you could see the expansion of matter, where there is no gravity, they're just expanding and they're just moving away. But from our point of view, the resulting reality, when we don't see the expansion, we see a natural orbit effect. And so that's why they actually orbit. And because if they are going into opposite directions, they are never going to collide. And everything is just relative motion from our point of view, relative motion effects, because we cannot see the expansion. So any kind of orbit will actually just counteract gravity. But gravity is still there all the time. All the distances are reducing in the universe, and that's why everything is accelerating, and that's why all the distances are accelerating, because distances always reduce. So our solar systems, to see that it is expanding, you would have to compare with other solar systems that we are not connected to, and you would just see that the distances reduces. But if we are interconnected with other solar systems through other planets orbiting, then what happens is that they always remain at the same distance, because of this relative motion effect. So, and then and at a smaller scale, closer to objects, you also have electromagnetism that can counteract gravity.
So gravity is not a force; it's just everything expanding.
It's not a force. It's just the expansion of matter, and the geometry of expansion will explain, what you will see in the universe, all the orbits and the reduction in distance of objects. Like if an object is falling down to Earth, the Earth is expanding towards it and catches up with it at an acceleration. The Earth is expanding at 4.9 meters per second, and then with the acceleration, then it becomes 9.8. So 9.8 meters per second. So that's compounding. It quickly multiplies. So gravity is not a force. It's just the geometry of expansion, because everything expands.
How did you get to the 19-minute number?
So Mark McCutcheon has got equations, a new equation to calculate gravity, which is, the original distance multiplied by the amount of time squared and multiplied by the expansion rate. So it depends on the expansion rate of matter and the radius of objects, of the both objects, and then divided by the relative decrease in distance, which is 1 minus expansion of matter multiplied by time again square. So it's got new equations, and then his new equation it depends. He can calculate that everything doubles in size every 90 minutes, and he can calculate the 9.8 meters per second square acceleration downwards towards Earth as gravity, because of the equation that he come up with, and it's all based on the expansion, the radius of the objects, and as I say, the time and the distance between them, and all depending on the expansion rate of matter. So this is how he was able to come up with the 90. You can calculate how much time it would take before an object actually takes to double in size, and it's our universal, because expansion rate is universal everywhere. So every 90 minutes everything doubles in size.
What about redshift?
Now redshifts, there's redshift is based on the sound, the Doppler effect in sound. They thought that light was the same, but the problem is that it's not. And so when you see a redshift in space, they think that it gives them the idea of what the distances are, or of how the object is, the direction of motion, and so, but it's not. You can get a redshift just by having dust between what you're observing and an object. So it's no indication of anything. It's not really reliable. So we think that the universe is expanding at an extraordinary rate, and even more. And we came up with the idea of dark energy and dark matter to explain all this. Oh, this is all gone. This was just fudge factors to make Einstein still works to explain the cosmology of the universe. And it's pretty clear to everyone. And you read the headlines everywhere in your magazine. magazines. We need a new theory because Einstein cannot explain any of this. I'm sure they'll find a way to fudge this or to come up with new equations on top of new equations to be able to still keep these ideas. But it's clear that something is truly wrong here. So to measure distances in space, the universe is not expanding. It is expanding in the sense that it will double in size around 10 minutes, but we cannot see that because everything expands at the same distances, and we cannot see this expansion. But from our point of view, it's not expanding. Everything is mostly static in the universe, and galaxies are clustering together, and that's just what you see when you look in a telescope. So all this idea that there was this Big Bang and everything is expanding ever faster, this is probably all wrong, and it's all based on this redshift idea that is like the Doppler effect. It is no indication of distance, it's not no indication of direction of motion, and it's no indication of speed, basically. It may give you a good idea, but there's nothing reliable about it, and they are aware of that. When they're doing the calculations, there are maybe 3 different ways by which they can measure these things, but I think they've got it probably completely wrong, because once an idea is out there, everybody's trying to explain it by any means, and then if you give them enough time and enough millions of people working on this, they will come up with something, and so it's like the moon, the gravity on the moon. That's you had an interview recently with someone who said that probably the Apollo missions were fake. So when we were on the moon, they say that we calculated that the gravity on the moon was 1.6 meters per second square, 1.62. Well, I don't think, and this is 1/6 the gravity of the Earth. But if you look at the moon, it's 4 times smaller than the Earth. And if you look at its radius, gravity on the moon should actually be 2.6 meters per second square, not 1/6. It should be 1/4, a bit more than a quarter. And so, from a perfect orbit around the moon, this is definitely what you will get. But as soon as you're no longer in that perfect orbit, and you're falling down kind of in an arc way, or straight down, then it could be 1/6. Despite the fact that it's one. It should be 1/4, but I don't think it's likely. I think that, and that will explain why half the unmanned missions have crashed on the moon. They were expecting 1/6 before they went, and this is what they confirm. And if these missions were fake, then obviously it was never verified. And so I think it's probably 1/4. And now, when you look at Mars Mattis and Mark McCutcheon, when they tried to their theories and their equations to try to justify what it would be on the moon, they assumed that 1.6 was correct, that it was 1/6, and then they tried to explain it. I think Mars explains it with his charge field, but Mark McCutcheon explains it by the fact that it's 1/6 on the near side, but it's actually 1/3 on the hidden side, because the density of the moon is totally different. It's much more dense close to the Earth because of the original formation of the Earth-Moon system. So to altogether, added together, 1/3 and 1/6, and then a quarter at the edges, it gives you exactly that, 1/4 of the gravity of the Earth. And the Earth, the center of gravity is more towards the center, because the Earth was spinning at the time, but the moon was not spinning. We always see the same face of the moon. So definitely there is a degradation of density of matter. Gravity also. Once you're on the ground, gravity is also when you are being pushed up by the object itself. So the density of matter is important then. But I don't think there will be that much difference. I think that it's probably a quarter all around, maybe a bit less on our near side and a bit more on the other side, because gravity goes from the center of mass, and if it's nearer our side, then there will be more expansion towards of the matter towards where the other side of the moon is. But I think for Mars it's probably 1/6 all around, 1.6 meters per second square all around. I'm not sure, I'll have to double check that. People can check this on his website, but I think it's probably a quarter, but I can't be sure. Maybe the Apollo missions did happen. I can't be sure.
What do you think? Do you think they did happen?
To be honest, I don't know. If I had made a massive research on it, it's very difficult these days to say anything, because you need to research everything, and writing a book or two maybe. So I can't be sure, but very people are very convincing. Many people they are experts in their fields, and they've written all these things, and it will explain a lot, because it doesn't make any sense that gravity would be 1/6. Originally they thought it would be 1/6 because they had the wrong mass, and this is all because we use Newton's and in his equations, which are based on mass. But if everything is based on expansion, only the size counts. Gravity is like from surface to surface of expanding objects. It's no longer mass, and that's why they had the wrong mass and they had the wrong density as a result. So what happens is that they thought that the moon was much less dense than it is, but it doesn't make any sense. I think that probably the moon has got the same kind of density than the Earth, on not that much more. So even on the moon, I would have thought that it would be 1/4. So, but maybe the Chinese will verify it and tell us the truth.
So what you're suggesting is that expansion theory is far more elegant in its explanation of everything.
Elegant, that's a nice word to use for theories in physics, which is totally meaningless. It's like string theory has always been declared elegant. I don't know what's elegant about it. It's a nightmare. And it's not getting them any kind of solutions anytime soon. It's doomed.
Okay,
sorry,
more
I might just said that.
Then. More pragmatic.
Yeah, it's more mechanical in nature. So that's very important. If you've got a theory in physics, you've got to have these particles. You've got to be able to explain their interactions, and you've got to explain why things happen. It's like this natural orbit effect, for example, or gravity, distance is reducing, and you can visualize this because you can see the God's viewpoint behind the scenes, where you can see the expansion. And that's one perspective, the God's viewpoint. The second is what we see now resulting in reality. But there's a third perspective, which is once you've seen the relative motion effects, what is really happening then at that point? Because for the moon to orbit the Earth, if they are expanding, we don't see this, and it looks like the orbit is very stable. But if the Earth is expanding, technically the moon is also expanding, and it's moving into enlarging spirals, and all the orbits in the solar systems as well. And this is why they are expanding, and that's why they double in size. These objects and all these orbits and all these systems. So there are different perspectives to help you to actually visualize exactly what is going on. So I don't know if we could say that it's elegant, and I'm not sure any theory in physics is elegant, but does it make sense? And then is it easy to understand? Can a child understand it if he's 10 years old? Yeah, probably. If I take the time to explain, I'm pretty sure that they would. And much easier as well than an adult who actually knows about physics and Newton and Einstein, because then they get very confused. When I was a kid, for me, when I look at particle physics and when I look at astrophysics, they were the same. It was obviously the same. I just had to figure out how. And it took me, a lifetime. So to figure it out, but I have, it is the same thing. And once you've got these theories and to explain things, and they contradict the fact that, oh no, particle physics is totally different from astrophysics. What you see in the night sky has got nothing to do with what you see in a microscope, or a very powerful microscope if you want. But they are the same thing. So electrons are, solar systems, galaxies are atoms, and then cosmic molecules are, galaxies linked together. And all of this must be. There are lots of rogue planets and rogue solar systems in the universe that are outside the solar systems, outside the galaxies, and we have never paid attention to them because they are very difficult to see, and only solar systems can be seen, and even then very difficult, with great difficulties. So now it's a prediction. I'm telling you that there are those things, so we should look at these, how they are linked together, because all these particles are linked together. And we can see that now. There are some discoveries of patterns in the universe with galaxies that, are in strange shapes. They obviously kind of link together. How do you explain that? And what do they represent? It's very difficult to see because we don't know, because of the distortion, because the path of light changes all the time. Sometimes you can see an object twice because it has taken different paths to get to you, and then you see it in different locations. But there are patterns out there. And so yeah, this is interesting.
It sounds extremely theoretical, and at the risk of it becoming sort of academic masturbation, what is the real world application of theories like this?
It's the entire physics. It's chemistry. It's it will affect everything. from every point of view, so it is extremely important. It's how you explain physics and the right equations to explain everything. And how you build plane, for example. How do they fly? If the Earth is expanding, they're constantly going higher. How do you explain orbits for satellites, for example? In lower orbit, they go faster. And if you want them to go higher, into a higher orbit, then you've got to accelerate. But once they have accelerated, they suddenly go slower into orbit around the Earth. How do you explain all this? And you can explain that easily with the geometry of expansion behind the scenes. And so
but planes do fly. Sorry, but hang on. But planes do fly.
They fly, yeah. But I mean to say is that if the Earth is not expanding, it's actually always at the same altitude. But if the Earth is expanding, it must be always going upwards. And so their wings are making sure that they're always going up higher, because they must go into a spiraling upward way to counteract the gravity of the Earth. And so there's a lot, and why a satellite can remain in the same space, a geostationary orbit, above your house without moving at all. And this is also the expansion of matter. It is actually in orbit and it is moving, but it's in with the rotation of the Earth. And then so as the Earth expands and rotates, the satellite is probably moving in a completely straight line. The distance reduces, but they will always remain at the same place, and then you will have a natural orbit effect again, and then you can explain why actually it's at the same place. Otherwise, it's a total mystery. And so once you've got a better understanding of everything, like the speed of light might be accelerating, it changes everything from any kind of invention about energy, or because it's not just light, it's also, energy. It's magnetic fields and electrical fields. This is all what technology is about. And there could be a massive, big revolution. Like quantum entanglement is not exactly something that it's completely misunderstood. And Mars Mattis says that they are not even interconnected. They are just synchronized like clocks, and they spin. And I think this is a very good explanation. But quantum entanglement can also be explained by the fact that if two particles are entangled, they are actually they are connected together by a big field of particles between them over long distances, and when one particles change, the other one as well. So there's a lot of different explanation. They're trying to build computers on this and lots of technology, so they better understand exactly what they're dealing with, you see. So it's crucial. And chemistry as well, it changes a lot of things. So and all science, I would have thought.
What about vectors like wind?
Vectors like wind.
Does wind expand also every 19 minutes?
Wind. So if you look at wind, it's made of air molecules. So all the molecules are definitely expanding individually, all the particles. When you got a gas, it's very kind of chaotic. Everything is kind of spaced out, and it's vibrating faster. And but what is interesting about wind is that the air molecules are definitely expanding, but the Earth is expanding and in all directions around the Earth, and so that's what creates the pressure of the weather. So all the winds and all the atmospheres are being pushed out, and see if you got mountains and if you got oceans or a different kind of geography down below, it will push the wind in certain directions, you see. So yes, the wind itself, very interesting questions. Does the molecules of the gases composing the wind are expanding, doubling in size around 10 minutes. But as I was saying, that the Earth is expanding in every directions, everywhere. This is why the atmosphere is not lost into space, and this is what creates the weather and the pressure and the problems, because of the different geography of the Earth, like mountains and oceans, or just normal hills. So it pushes the wind in different directions.
How can I follow your work?
So if people do a search on Substack or on Medium, I've got a lot of articles there. A lot of my chapters are free to be read, all the most important ones. Also, I've got a website which is themarginal.com. The Marginal, so THEMARGINAL.com. So from there are links everywhere else. I'm not that I'm not that much on social media. I do have all the accounts, but I'm not using it. Otherwise, I wouldn't be doing any work. I don't know how Elon Musk does it. He's always and Trump. Are they always tweeting? Do they do anything with their days? I don't know.
I can't pronounce your name in your native language. I'm going to say Roland Tremblay. Thank you for joining me in the trenches.
No, thank you very much. It was a pleasure.